we are Sara Campos from Surti in Paraguay, Raymond Sarmiento and Jaymar Tordesilla from GMA News in the Philippines, and Nicolás Russo and myself, Lucila, from Grupo Octubre in Paraguay. So image to text is a tool that uses AI to identify, classify, and label content in video and photo archives in newsrooms. It is aimed specifically for newsrooms, and one of its main objectives is to promote better data governance by including different contexts from the larger world. We are going to go a bit deeper into this concept in a few moments. It is an API which anyone can download and install and use, and it also comes with a starter pack. This is a guide of steps to follow and best practices to incorporate this kind of technology in any newsroom from everywhere in the world. It is aimed especially at maybe small newsrooms or newsrooms that think of AI as something that is out of reach for them, something that they still don't know how to incorporate, or they don't know that they can incorporate. So our main message in the starter pack is that anyone can do this. We did it, we went through this process, so we wanted to share what worked for us and what didn't. It is also used for those who want to use the API that we created, but also for those that want to use, for any reason, other tools. Okay, so now I'm going to speak a bit about our motivations for this project. So as you probably know, there are available in the market many services that are really good, are really effective at describing images using AI. But what we found when we started researching is that they are not necessarily designed for journalistic purposes and context. As an example, when we uploaded a video of Alberto Fernández, the president from Argentina, meeting for the first time with Gabriel Boric, the president of Chile. And one of the tags that we got as a description for context was first date. I mean, I guess in a sense it was a first date, but we don't know why the system described it in this manner, maybe because there were many suits, we don't know. But apart from this kind of funny example, the other tags that we found weren't useful as well, even though they were accurate. For example, we got red carpet, and there was a red carpet there in the video, but it's not relevant for journalists. No journalist is going to look for this video typing red carpet. So we figured out that we needed AI services, image recognition services, more suitable for our specific context. Another of our motivations was that we know that AI can help make the process of classifying and tagging content in big and large archives more efficient. This is a process that takes a lot of time, a lot of resources, and a lot of work, and AI can make it better. And our broader motivation, and this inspires the use case that we created and that Sara is going to describe better, is the lack of representation from different countries and different cultures in the AI ecosystem. For example, when we started researching and we ran our first trials, we uploaded pictures of the presidents of our three countries, Argentina, Paraguay, and the Philippines, into Amazon Recognition, and it didn't recognize neither of them, and these are presidents. So you can imagine what happens when to a broader set of political and cultural figures. And also, we know that the AI ecosystem isn't that representative of different cultures, different groups, different minorities, ethnic groups, and so on. This works the same way. This works both ways. For example, what we are doing here is our input is text and the outcome, sorry, it's the other way. Our input is an image, a picture, and the outcome is text. But for example, if you use DALL-E, in which the input is text and the outcome is a picture, this also different groups, minorities are also underrepresented in the outcomes. So our big hypothesis is that if different people from different parts of the world, different countries, different cultures start to build data sets, train more models, they can contribute and we can contribute to debiasing this AI ecosystem. So if databases are produced mainly in, for example, the US or Europe, well, they are not going to be representative, even if those producing them aim to make them representative. It's probably going to be more inclusive if there are many groups in different parts of the world contributing to this kind of technology and training these models. So from a user perspective, the benefits of the product that we created is that it facilitates access and search of multimedia content for newsrooms. Also that it generates metadata that can optimize search engine strategies and at the same time improve accessibility, for example, for visually impaired people, and that it learns from a more diverse training data set and include different categories and backgrounds for inclusion and representation. So now I'm going to pass the microphone to Sara, and she's going to explain a bit more into detail how we build this and how the system works.
Thank you, Lu. Can you go to the next slide, please? Thank you. So in line with what my colleague Lucila was saying, the main objective of this project is to make image recognition more accessible to newsrooms and consumers, whilst at the same time increasing representation within the training sets. This is what we have been working on. And we believe it is necessary to feed the models with diverse training sets that will not only improve the performance of the models, but also address the potential impacts on specific individuals and society as a whole. And what I want to share is that this has been the backbone of our project, and it led our entire strategy from designing the system to validating the data sets. And how does image to text works? It breaks down into three main categories, and we try to overly simplify it over here. It is obviously a bit more complex, but basically we have a processing part, which involves a lot of data processing, and then testing and training, and then the deployment of the API. Within data processing, it involves the collection and formatting of all the images and videos that we gather to create our data sets. Then image annotation and tagging, which was a really long and manual work, and then feeding this entire information within a JSON file that could be trained. Then within the testing and the training part, we divided into three main categories or three main sets. This is something that happened naturally, and then when we look back at it, this is what happened. We divided our data sets into training. So this is the last part sort of, or the what hold up the entire project all the time. We use a data set to specifically train the model. And this is where we focus specifically on women that are political leaders in our countries. So Argentina, Brazil, and Paraguay. But we also use some data sets to validate. So that was the validation part, in which we needed to fine tune the results that we were finding in order to have more accurate descriptions or labeling, as well as improve the accuracy rate. And then we had a testing part that allowed us to evaluate the performance of the overall model. And then on the other hand, it required executing a pre-trained model to see results. This happened throughout the last 4 to 3 months of the fellowship, it was an iterative process where we would feed the model with the data sets, and then it would give us back the results. It is a JSON file. We still have the results as a JSON file, and then we would go back to our training sets and adjust what needed to be adjusted, or provide more data to our model and get back to the beginning, right? And then in terms of the deployment, at this moment, it is done through a container bucket in Amazon Web Services. So we built an API that you can easily use on AWS servers, exclusive for now. At some point, we want to make it cloud agnostic. Can you go to the next slide, Lou, please? And this is the part when I want to focus on a specific case study. Given the time window that we had, it was a really short period of time, we decided to focus our attention to fine-tune our pre-trained model to recognize women political leaders from our country. And this test was really important, not only from a political stance. Women, and especially women from the larger world, are mostly impacted by these tools, but also because it allowed us to understand how the model actually worked and how long it would take to train the model on a wide range of new parameters in order to improve accuracy and representation. This implied a lot of work to gather the data and to put it in the right form, as I mentioned previously. And from our experience, or what we are bringing here, is that data preprocessing, especially for image recognition, but I think for any other system, is a really time-consuming process. It is a manual process. And in our case, it is mostly done manually, since we feed the model with training sets that have very new criteria. Once we collected the data and properly prepared it, we fed it into our model, and we had pretty exciting results. This is the case of Senator Pia Cayetano from the Philippines, where we provided a whole bunch of images, a JSON file with labels, descriptions, and videos. And it only took a couple of trials or tests to improve the accuracy rate and to recognize her. As you can see, overall, the accuracy rate is 99.9%, and that's pretty exciting, and it's quite a really nice result. Obviously, the pre-trained models are really good at recognizing once you point the right direction. So I think that's the most important focus that we have to give to our training sets, is that to point exactly where it has to go and how to accurately describe people. And then with every single data set that we provided on her, the model was able to identify her in any situation once it trained, or once we trained it, right? And this is how we went for most of the data that we provided on women in politics in our countries. And it was really, we were really happy to find these results. Lou, can you go to the next slide? Thank you. We still have some challenges to tackle, and this is like sums up most of the challenges we had to go through. Obviously, the major constraint towards our final goal was, and still is, time. It is a really time-consuming process, but the first stages of getting the model up and running require many hours of work, and one of the most time-consuming features is preparing descriptions with NLP, because the first step was tagging correctly. Then we have to review descriptions, which will be a feature that will come in the near future to allow us to describe also within a human rights perspective the different people, since we are doing people's recognitions in the images. And then making the overall system cloud agnostic is another challenge, and it will require many hours and resources due to its complexity. It's achievable. There are many products that are available in the market that are cloud agnostic. They just require many resources to get into place. And then in terms of these challenges, we see them as challenges, but also opportunities. And these are included into our roadmap, and we wish to tackle in the near future. And Lou, you can go to the next slide. Thank you. And so what's next for image to text? We know at this point that we need to design an interface that will make it easier for users to use our API and also feed the model to make it more accurate and robust. So that's one of our main interests in the near future. We want to open the model to everyone who is interested in using it and contributing. And this also implies simplifying the access to it and reducing the complexity of implementation. Once we have achieved this, we will probably have to establish an initial pricing strategy because we will probably will be using very very pricing servers. Then we believe that we will need to add the description feature. And this is important because it will facilitate content writing for SEO purposes and also accessibility for visually impaired people. And at the same time, we are looking into different paths, that we need to take to develop image to text as a cloud agnostic API. And to make this possible, we obviously need time and the funds available. And then I want to share one of our main takeaways. Building AI systems, and as Lucila already previously mentioned, do require collaboration from everyone, from journalists to audiences. And we think that we are at a time where AI models are no longer for the few. And in order to make them work for us in a fair way, we need to include people from different backgrounds. And we believe this would make image to text useful to numerous contexts, as it has the potential to be adapted to all sorts of situations. We also think that it is the most important, this is the most important learning that we have acquired and also tested during the past 6 months. And we hope we will able to share this in this presentation with you. Thank you for listening, and we're here to respond to your questions.